So you have a lot of experience finding derivatives of functions. But what if you're given the derivative, like this one, f prime of x equals 2x, and you want to find what did I differentiate to get 2x? In other words, you want to find the antiderivative of 2x. You're going backwards. You're given the derivative and asked to find the function that you differentiated to get that. Now the way we're going to ask for that is we're going to use this little symbol right here. This is an integral symbol. Integral. Integral. And I'm going to put the 2x in here, and that 2x is the integrand. Okay, integrand. And then we put a little notation on the end, the dx. And this dx simply tells us what is our independent variable. In other words, we differentiate it with respect to what to get this. So in this case, this is telling us that x is the independent variable. So here's what we do. We say, well, what did I differentiate to get 2x? Well, if you think about it a minute, you'll see x squared. That's what I differentiated to get 2x. But if you think about it a little more, you say, well, maybe I differentiated x squared plus 3. Because so here's the deal. Yeah, x squared is an antiderivative of 2x. If you differentiate x squared, you do get 2x. But also, x squared plus 3. If you differentiate that, because the derivative of a constant is 0, you get 2x also. In fact, you could say, there are an infinite number of things I could differentiate to get that, but they all just differ by a constant. In other words, they're all going to be of this form. They're going to have an x squared in them, but then they're going to have a constant added to it. So all these infinite antiderivatives, all the things that you can differentiate to get 2x, they all differ by a constant. X squared plus 1, x squared plus 2, x squared plus pi, and so forth. So when we are asked for an antiderivative, it will be done this way, with this little integral symbol. And then we just have to go and find, well, what did we differentiate to get that? So let's look at another example. Let's suppose we've got x squared. We want to find the antiderivative of x squared. Well, let's see here. When you differentiate, you go down a power. So you might say, well, this is x cubed. Oh yeah, plus a constant. Don't forget the plus a constant. Now let's see if this works. In other words, if I got this right, when I take the derivative of this, I should get x squared back. So let's see here. If I differentiate with respect to x, I'm going to get 3x squared. Yeah, and the derivative of c is 0. Well, that's not what I wanted. I didn't want 3x squared. I wanted x squared. So it looks like what I need to do is counteract this. In other words, I'm multiplying by 3 here, so I need to divide by 3 to kind of counteract it. So here's what I have. I have x cubed, x squared. And what I need to do is, I can call this x cubed, but I need to divide by the 3. This is my antiderivative. This represents all the antiderivatives. See? Because now if I differentiate that, look what happens. The 3 comes forward, it divides with the bottom, and I just get x squared. Now this illustrates the power rule for integration. And remember, there's a power rule for differentiation where we multiply and then we subtract. Well, for integration, we're going to have something like this. We're going to have x to the alpha, where alpha is a real number, and we're going to say 1 over alpha plus 1. See, it's like this, where 2 is alpha plus 1, x to the alpha plus 1 plus a constant. That's how we can find that antiderivative. Now, you might say, well, what about a situation like this? What about if we have the square root of x? Remember, once we learn the power rule for differentiation, we learned that, well, before you do anything with this, you need to convert it to a fractional exponent. And now we can use the power rule for integration. We've got 1 over 1/2 plus 1. Let me just call it 2/2. X to the 1/2 plus 1 plus c. There it is. And if you work that out, you get 1 over 3/2 x to the 3/2 plus c. Or, you know, we could flip this. 1 divided by 3/2 is 2/3. And there we have it. We found our antiderivative. So if you differentiate this, you'll end up with x to the 1/2 power. Now let's look at some others. Let's suppose that we've got 1 over x to the 4th. Well, once again, we want to use this power rule for integration. We want to use this idea right here. So I need to write this as an exponent, in the top. I don't know how to deal with this in the bottom other than just to move it to the top. So I'm going to write this as x to the -4 dx. And now let's see what I have. I have 1 over -4 plus 1, x to the -4 plus 1 plus c. Now you have to be careful because, this is not going to be -5. You're diminishing, right? You're adding 1 to this negative. So what you're going to get is x to the -3 plus c, and there is a -3 down here. Yeah, so you might write that as -1/3 x to the -3. Or if you want to put it back like you found it with the variable in the denominator, this might be -1 over 3 x to the 3rd. Okay, so there you have some examples of how you can find the antiderivative for square roots and the negative powers. What if you have a combination here? Let's suppose that we have, let's suppose x to the 4th plus 3x to the 2nd plus, let's say, the square root of x. And we'll just put all that over x. Okay. Now remember, the only tool we have so far for finding antiderivatives is this power rule for integration. So let's see what we've got here. Let's see what we can do. You can think back at how we would deal with something like this to differentiate. And remember what we do, we can kind of split it up. Give each one of these numerator components its own denominator. Yeah, like this. See that? And then we simplify that a little more. So then we've got this. We've got x cubed plus 3x. Let's see what this is going to be. Plus x to the 1/2 minus 1. See, just doing a little bit of division there. Let's see what that gives us. This gives us x cubed plus 3x plus x to the -1/2. There, almost done with this one. Okay, so now we just go through here and use the power rule individually. So we've got 1/4 x to the 4th, see? Plus 3/2 x squared for this one. Now you got to really watch your bad self on this one because it's got a negative involved. So let's see what we've got. We've got 1 over -1/2 plus 1. X to the -1/2 plus 1 plus c. So let's see what we've got here. We've got 1/4 x to the 4th plus 3/2 x squared. Now, plus 1 over 1/2 x to the 1/2. Okay? And then, to clean it up a bit, we've got 1/4 x to the 4th plus 3/2 x squared plus 2 x to the 1/2. Oh, I forgot the plus c up here. Look at me. It's easy to forget the plus c. Okay, so there you have it.